Hi guys, so today we're going to do kind of an introduction to trig identities, so make sure that you have your notes out. Now you'll notice the first part of this is actually going to be very similar to not what we did this past unit with graphing and inverses, but the one before that, where you had to kind of the intro to trig where you had to draw the triangles and such. So make sure these are all review. Those identities knowing cosecant is reciprocal of sine, etc. So we're just going to jump right in. It gives you secant of theta, find cosine of theta. Well, we know that those two are reciprocals of each other. So that means cosine of theta is just the opposite, or -3 over square root of 30. Okay, because secant and cosine are reciprocals. Now, I don't want a square root in my denominator, so I'm going to rationalize. And I get -3 square root 30 over 30. There's one last step I can do to simplify, and that's the 3 over 30 simplifies to 1 over 10. And you can put the 1 or you could not, but it ends up with a final answer that looks like this. All right, next, let's do number 2. This is again where I gave you very similar problems to this in 2 units ago. My recommendation is first to figure out what quadrant you're in. So tangent is positive, but cosine is negative. That means we're going to live in quadrant number 3, tangent positive, cosine negative. From there, once you do that, even though it gives you 2 different options, just focus on one of them and then use Pythagorean theorem to find the third side. Otherwise, the simplifying gets a little messy. So we know tangent is opposite over adjacent. So opposite, remember theta is always at your origin, and adjacent. And I also know both of these will be negative because I'm in the third quadrant. All right, so to find the hypotenuse, I'm going to use Pythagorean theorem. So negative square root 2 squared plus -4 squared is my hypotenuse squared. So that's 2 plus 16 is my hypotenuse squared. So my hypotenuse is the square root of 18, or that can be broken up into 9 times 2, or 3 square root 2. Remember, your hypotenuse is always positive. All right, so then what I can do is find sine of x, which is opposite over hypotenuse. So opposite is negative square root 2 over hypotenuse is 3 square root 2. Now those are going to, I can cancel out my square roots of 2, so it's just -1/3. All right, flip to the next page. Now these identities that you see here are very, very, very important, especially this first one. You're going to use that a lot. Now you don't have to memorize the other two necessarily because you can derive them. So I'm going to show you if I do cosine squared of theta plus sine squared of theta equals 1. If you have this one memorized, let's say I divide everything by cosine squared of theta. In my first part, cosine squared divided by cosine squared is just 1, plus sine squared over cosine squared would be tangent squared of theta, equals, for the last part, 1 over cosine squared is secant squared of theta. Notice that's exactly what I have in the second part here. You could do the same thing to get the third one, but instead of dividing everything by cosine squared, divide everything by sine squared. So that's just a reminder, you need to memorize the first one, but if you have that one memorized, you can get the other two. All right, so let's do another one, number 4. Number 4 is very similar to what we did on the front. We first need to figure out the quadrant. So it says sine is negative, which means our y is negative, and cotangent is also negative. So that means I'm going to live in quadrant number 4. All right, sine is -1/3, which is opposite over hypotenuse. Hypotenuse is always positive, so that means the 1 is negative. I also know the 1 is going down. I'm going to use Pythagorean theorem to find the third side. And when I simplify that, I get 2 square root 2. Okay. All right, it tells me to find both cosine and tangent. So I'm going to start with cosine, which is adjacent over hypotenuse. So that would be 2 square root 2 over 3. I can't simplify that all, and I have no square roots in the denominator, so we're good there. And then tangent of theta is opposite over adjacent. I do need to rationalize here because I have a square root in my denominator. So I get -1 square root 2 over 2, and then square root of 2 times square root of 2 is 2, so that's 4. So that's what I get for tangent of theta. All right, so then we have the cofunction identities. And how to kind of think about this is if you have like a 30, 60, 90 triangle, the sine of 60, for example, right here, is equal to pi over 2. Remember, it's just 90 degrees. So is the same as cosine of 90 minus 60. So for example, if we had, I know this 3, 4, 5 isn't true for a 30, 60, 90. But if you had, okay, so sine here would be 4 over 5. That's the same as the cosine at the other angle. Now, you don't really need to know kind of that whole why behind it, but that's where this comes from. How a lot of times kids remember it is cofunction identities, or sine goes with cosine, tangent goes with cotangent, secant goes with cosecant. So again, that's just kind of the way to kind of remember it. Lastly, we have this even odd. So the only functions that are even are cosine and secant. And what even means is it's a direct reflection over the y-axis. So if we go back to our graphs for a second, let me find the picture of our graphs. Here we go. Okay, so if we look at the cosine graph, we can see that at pi over 2 and at negative pi over 2, the graph has the exact same value. At pi and at negative pi, the graph has the exact same value. And same for secant. At pi and negative pi, opposites, it's a direct reflection over the y-axis. If I look at something like cotangent, for example, well, yes, this is true on the x-intercepts, but if you look at pi over, what is that, pi over 4, if you look at pi over 4, it's at +1, but at negative pi over 4, it's at -1. So those are completely opposite, which means they're odd. So if we look at that here, cosine, basically if you plug in negative theta, you're going to get out the same thing. That's the idea that at pi and negative pi, they're the same thing. At negative pi over 2 and pi over 2, they're the same thing. The other ones are going to be odd. So let's look at what this actually looks like. So sine of negative theta, okay, sine is odd, so that's the same as negative sine of theta. Okay, and I'm going to go ahead and solve for sine of theta here. Well, we know sine is odd, so that's how we know sine of negative theta is just negative sine of theta. And then if I divide everything by -1, that means sine of theta is positive 0.97. All right, then I see this weird thing going on here, cosine of pi over 2 minus theta. Well, if I look up here, cosine of pi over 2 minus theta, that's just a fancy way of using your cofunction identities to say what is sine of theta. Because this right here that I just circled is sine of theta, and that's something that you just have to recognize. So what is sine of theta? It's 0.97. All right, let's look at another one. Tangent of negative, that's an alpha. You can just use A if you want. So I know tangent is odd, so that means negative tangent of A is negative 0.236. I can pull that negative out front since it's odd. Well, if negative tangent of A is negative 2.36, that means tangent of A is 2.36. Okay? It wants me to find cotangent of A minus pi over 2. Now notice this doesn't look exactly the same right here because the pi over 2 is in the front. But I can get it to look like that by factoring out a negative. Like this. So now think about if you were to distribute this, the A would be positive, the pi over 2 would be negative. Well, cotangent is also odd, so that negative can be pulled out front. Okay, And let's think about cotangent of pi over 2 minus a. That is the same as tangent of a, okay? The only thing we don't want to forget is we are really trying to find negative tangent of a. Okay, so negative tangent of a, we actually already had that up here. That's going to be negative 2.36. This is usually the hardest part of this unit, is this little section right here, just getting used to kind of those even, odd, and cofunction identities. All right, let's go to the next page with some simplifying. This is the fun part, or at least I think it's fun. So always, we're going to go through the odds. We want to rewrite them in terms of things that we know. So for example, I usually start by, if I notice that they can be written with sine and cosine, I start there. So 1 over cosine theta is secant of theta. And then tangent is sine over cosine. I'm going to go ahead and clean this up. I know sine of theta times sine of theta is sine squared of theta. Now, these already have a common denominator, so I can go ahead and rewrite this as 1 minus sine squared of theta over cosine theta. Well, let's go ahead and think back. We know sine squared of x plus cosine squared of x equals 1. If I were to subtract sine squared of x from the other side, this is really just cosine squared of theta, and that's one that you'll get really familiar with. Same thing as 1 minus cosine squared is sine squared. All right, from here, I can cancel out one of the cosines, and I'm just left with cosine of theta. All right, let's look at another one. Cotangent squared minus cosecant squared. A lot of times there's a lot of different ways you can do this. I'm going to go ahead and write this as cosine squared of theta over sine squared of theta minus 1 over sine squared of theta. All right, I already have a common denominator, so this looks like cosine squared of theta minus 1 over sine squared of theta. Now, cosine squared of theta minus 1, let's look at our original right here. If I minus 1 on the other side, okay, it looks like this. And then I want to get this by itself, cosine squared of x minus 1, because that's what I have. That's going to end up equaling negative sine squared of x, because that sine squared will go to the other side. So I get negative sine squared of theta over sine squared of theta, and that's just negative 1. All right, so next for number 5, I'm going to write that as 1 over sine of theta, and then cosine squared of theta over sine squared of theta over 1 over sine of theta. So that's a lot going on, okay? But all I did was just rewrote in terms of sine and cosine. When I'm dividing by a fraction, remember you can multiply by the reciprocal or keep change flip, so it ends up looking like this. And I'm just going to look at this part first, okay, where I multiply by the reciprocal. I can cancel out one of my signs from the top and the bottom, and that will look like 1 over sine of theta, that's still just my cosecant, over minus cosine squared over sine of theta, because that one sine canceled out. Because I have a common denominator, I can go ahead and combine that. Remember 1 minus cosine squared, that's the idea up here. 1 minus sine squared is cosine squared, so 1 minus cosine squared is sine squared of theta. Over sine of theta just gives me sine of theta. All right, so let's look at the next one. All right, so on this one, I'm going to rewrite secant as 1 over cosine of theta over sine of theta, or I guess we're looking at u right here. Sorry about that. Minus sine u over cosine u. Okay, well, 1 over cosine u divided by sine of u is just 1 over sine u cosine u. You could also think about it as keep change flip with sine of u over 1, which turns into multiplying by 1 over sine of u. Okay, minus sine of u over cosine of u. Now be careful here because you don't have a common denominator. So I need to multiply this one by sine of u on the top and the bottom. And I get 1 minus sine squared of u, sine u times sine u, over sine u cosine u. All right, going back to what we know before, 1 minus sine squared of u is cosine squared u over sine u cosine u. Now I can cancel out one of my cosines, so I'm left with cosine u over sine u. Now we don't want to leave our final answer like that. We know what cosine over sine is, and that is cotangent of u. All right, next I'm going to go ahead and multiply this out, okay? You can think about that by using your box or using FOIL, cosecant of x plus 1, cosecant of x minus 1. Oops, minus 1 goes down here. So this is going to look like cosecant squared of x. These are going to cancel each other out, minus 1 over cosecant squared of x. Anytime there is only one term in the denominator, and only when there's only one term in the denominator, you can break that up into two separate pieces. So that gives me cosecant squared of x over cosecant squared of x minus 1 over cosecant squared of x. Well, that first term will just be 1, and then the reciprocal of cosecant is sine. So I get 1 minus sine squared of x. Again, I don't want to leave it like that because I know what that is. That is cosine squared of x. All right, and the last one. This one is going to be one where you want to factor because I see that tangent squared of y in both terms. So I'm going to factor that out, and I get 1 minus sine squared of y. Okay, because this, if I were to redistribute this, I would get tangent squared times 1, tangent squared times negative sine squared. All right, again, I know what 1 minus sine squared is. That's cosine squared. And I'm going to go ahead, you get kind of stuck at this point, but remember, you can always rewrite tangent in terms of sine and cosine. So I'm going to rewrite that. And then you should notice that my cosine squareds cancel out, and I'm just left with sine squared of y. So remember, your sine squared plus cosine squared equals 1 is your big one that you need to remember, and you need to be able to manipulate it to get different values as well. Even, odd, and then the first part, remember, is just the triangles. So reach back into Unit 6, and when we did some of that, picking your quadrant, and then drawing your triangle. Okay? Have a good rest of your day.